Go. All right, our lesson today is going to be on liquid mixture problems, or at least that is 2.6. When we get to 2.7, we'll continue with mixture problems, but they won't be liquids anymore. We'll be mixing up other kinds of things. All right, let's take a look at the first question. Sometimes, I'm going to go down here and write something. Sometimes I call these solution problems. Okay, so these are going to be my solution problems. Let me let you just listen to the very first question. It might be a little difficult for you to read on the screen, so just listen to me or look at your own paper. It says, how much pure acid should be mixed with, and it's a little bit crowded, but it says 4 gallons of a 60% acid solution in order to get an 80% acid solution. This is actually a very realistic problem. Maybe not with acid, but I want you to think about being in the hospital. And perhaps you have to have some IV drugs, okay? When the doctor orders your IV drugs, he asks for a certain concentration of the drug. The order gets sent to an IV pharmacy within the hospital. And I only know this because my sister-in-law used to run an IV pharmacy at Parkland Hospital. And my brother is a pharmacist also. So the order would come in. Now, they didn't just go in the storeroom and grab a bag that matched what the doctor wanted. They had to physically mix up the concentration that the doctor ordered. The mathematics they did to figure out how much of what to put in the bag is the same kind of mathematics we're going to do today. When we're in chapter 3, we're going to look at this again. It'll be a little bit different. It'll actually be a little bit easier because we'll have more knowledge. But we're going to start out today. Everybody kind of understand what we're doing? All right, when I do these problems, I like to draw a picture. It helps me with these. So I will go here. I've got my hard copy to look at. It says, how much pure acid should I mix with? Okay, pure acid. Here I go. I'm going to draw a little beaker, and y'all can get a big ha-ha out of my beaker. Okay, doesn't look, you can see why I didn't go into art. All right, I have got a beaker, and it's pure acid. Well, what percent of this is acid if it's pure? 100%. So I'm going to write 100% right there. Now, it talks about how much pure acid. So I'm going to draw a little line out here, which is going to indicate what the volume is, how much, and the answer is, I don't know. So I'll put variable x. How much pure acid should I mix with? So I'll put a plus sign. And then I'm going to draw another beaker. Okay, how much pure acid should be mixed with 4 gallons of a 60% acid solution? So this one is only 60% acid. Probably the other 40% is water. And it says how much of the 100% should be mixed with 4 gallons of this. So I'll put a 4 out here. Does that make sense so far? Okay, I'm going to pour those two together. I'm going to make a big old beaker's worth. In order to get an 80% solution. So I've got some pure acid. I'm going to mix it with some 60% acid. The pure acid is going to make this concentration stronger. The more I pour in, the higher the percentage goes of pure acid, of acid. Now, the question over here is, how much of this mixture are you going to end up with? Now, we're not going to have a number to write down there. But if I take X gallons from the first beaker and I add it to 4 gallons from the second beaker, I can write an expression. Can I call this quantity x plus 4? Okay. So, does anybody have a question about what I've drawn? Every time I do a liquid mixture problem, this is the kind of picture I'm going to draw. Now, from that, I need to be able to write an equation. The equation I'm going to write is the percentage kind of is the value of the solution. This is a very strong valued solution. This one not so strong, and this one's kind of in between them. What I'm going to do is I'm going to change this percent to a decimal. You cannot directly multiply by a percentage. You can't. You have to change a percent to a decimal. What will 60% turn into as a decimal? 0.6. Some people might say 0.60. What will 80% turn into? 0.8 or 0.80. And what will 100 turn into? 1. Because what I did each time was move the decimal 2 places to the left. Now, what I'm about to show you, at first you're probably going to say, well, what a waste of time. And it kind of is, but I want you to know why I'm getting something. All right, I'm going to write down that 1 times x gives me the amount of acid in here. All of it's acid, so hopefully that makes sense. Oh, well, anyway. I'm going to write down 1 times x. For the next vat, I'm going to multiply 0.60 times 4. And when I add up the acid from the first one and the acid from the second one, that gives me the acid from the combination. How will you write down how much acid is in here? Okay, there is x plus 4 gallons, and I don't know why that keeps disappearing, but how much of that is acid? 80%. So to figure out, this is an acid equation. The acid in the first one, and it's all acid, plus the acid in the second one, only 60% of it is acid, added up gives you the acid in the last one, which is 80% times x plus 4. Now, physically, what did I do? I multiplied the inside number times the outside number. Now, do you remember when we were solving our equations with decimals that we could move all the decimal points? So I'm about to undo what I just did. Okay, and it feels like you just ran around in a circle. Okay, I did. I know I did. Move this decimal 2 places to the right, adding zeros. Move this one 2 places to the right. Move this one 2 places to the right. And you end up with 100x plus 60 times 4 is equal to 80 times x plus 4. I agree completely that writing this equation down was kind of a waste of time. And in my next example, I won't waste our time with that with writing that down. But I didn't want you to be misled thinking that you can always just multiply by a percent number, because you can't. Percents have to be changed to decimals to use them. It's just that when I multiplied through by 100, I got back to these numbers. All right, there's my equation. Now I'm going to do what we have been doing. I'm going to draw my line. Can I simplify on the left? Yes, I'm going to keep my 100x plus multiply those for 240 is equal to, can I simplify on the right? Yes, distributive property. That's 80x plus 320. Is everybody okay with what I did on that step? All right, my next step is, do I have variables on both sides of the equal sign? Yes. So I'm going to eliminate one of them. Question? Okay, distributed here. That's 80 times x. Got it? Okay. So now I've decided to get rid of the 80x that's on the right. So I'm going to subtract 80x, subtract 80x. That was supposed to be a black line. Oh well. That gives me 20x plus 240 is equal to, those 80 and negative 80x are inverses, so that's gone, and it's equal to 320. Okay, now, the silly phrase I've used in the past is, where's the party going on? On the left-hand side, because that's where the variable is. So what do you need to get rid of? 240. So I'm going to subtract 240, subtract 240, because whatever I do to the left side, I have to do to the right side. That leaves me with 20x. Those 240s are inverses. Equal sign. What is 320 minus 240? 80. What's my final step? Divide. I need to divide by 20, the coefficient, divide by 20, and x is 4. Now, I was only looking for one unknown in this problem. Let's go back all the way up to the question. Well, I'll just go to the drawing. What does x represent?
The acid.
The gallons of pure acid. So we need 4 gallons. If I take 4 gallons of pure acid and I pour it in with 4 gallons of 60% acid, I will end up with an 80% solution. Now that's all MathLab asks of you. It says how much, and your response is 4. It is 4 gallons, but all you have to type in is 4. Now I'm going to ask you a question MathLab doesn't ask. When you have finished, how much of this mixture do you have? 8 gallons. Because you know x is 4, and you know you started with 4, so you've got 8 gallons. It doesn't ask that. If you were in a true laboratory setting, you would not only have a certain percentage that you were trying to come up with, you would have a certain volume that you're trying to come up with. Okay, but we'll save that kind of question for chapter 3. Or actually, I'm sorry, chapter 4. Okay, anybody have a question on that one? This in MathLab was question number 1. All right, let's look at question number 2. I'm going to scroll back up to where the questions are. I know that it's probably too tiny for you to read, so I'm going to read it out loud to you. Whoops. Number 2 says, how much pure acid should be mixed with 6 gallons of a 70% acid solution in order to get a 90% acid solution? I'll review those facts as we draw the picture.
It says 5.
Pardon?
It says 5 gallons.
It says 5. Oh, I'm so sorry. I did not realize that I was...
That says 5 too.
Okay. Well, if y'all don't mind, I'm going to stick with mine. Just change yours from 5 to 6. Okay? I know what happened, and it was just a mistake on my part as far as what I printed out. All right, let's look at problem number 2, if we'll do the one that I have. All right, how much pure acid is how the problem starts? Well, pure acid. What's the percentage of pure acid? 100%. And the question said, how much? Which means, what's the volume? X. It's unknown. How much pure acid should be mixed with? Does your problem have a 70% solution, or is the whole thing different?
It's 70.
It is 70? Okay, a 70% solution. And if you don't mind, let's go ahead and stick with what my paper has. Let me look at that. You know what? That is a 5. I'm sorry. I was using old lady eyes. Okay, and so it is a 5. It's not that I have a different paper, it's that I can't read sometimes. All right, so how much pure acid should be mixed with 5 gallons of a 70% solution to get a 90% solution? So I need to make this solution a lot stronger. Now here's the part that you have to always fill in that's not directly told, is how are you going to describe the volume of this? How many gallons is it?
X plus 5.
It's X plus 5, and you're going to do that each time. You're going to take the gallons from the pure, you're going to add it to the gallons from this one, and you're going to get an expression, not a number. Now, I'm not going to waste our time switching my percentages into decimals and then turning back around and multiplying by 100. We're going to go the fast, quick route. I'm simply going to take this number and multiply it by the volume. So what will I write down?
100x.
100x plus,
350x.
okay, now in the second one, I'm going to go ahead and write it down as a product, 70 times 5. Now there's no x there, okay, just 70 times 5. So I will get the 350 that you referred to. Equals, what are you going to write down for the last one? Times 90. So I'm going to take the 90 times x plus 5. Whoops.
So does it, I guess it would matter that the 90 would go first, right?
It does not matter.
It doesn't?
And the reason it doesn't matter, and you just gave me an opportunity, is because of the commutative property of multiplication.
Okay.
So whether it's x plus 5 times 90 or 90 times x plus 5, either way, it's okay. Now, I personally like to be consistent. It's kind of a thing with me. So I like to put the percent first and the volume second. The percent first and the volume second. The percent first and the volume second. That's a consistency thing for me, but it doesn't matter. All right. Is everybody okay with setting up the equation? Because you're going to get to do problem 3 in just a few minutes. All right. Now, can I simplify on the left? Well, I can do a little bit. This is, whoops, 100x plus just the number 350 is equal to, what am I going to do on the right-hand side?
Distributed.
I'm going to use the distributive property. So I have 90 times x gives me 90x, and I have 90 times 5 gives me 450. Is that okay?
Mm-hmm.
I have variable term on the left. I have a variable term on the right. I would like to get rid of one of them. Which one would you like me to get rid of?
The 98.
All right, thank you. That's the one I wanted to get rid of also. So I'm going to subtract 90x from both sides. That gives me 10x plus 350 is equal to, those 90x's are inverses of each other, and I end up with 450. Now, I need to focus on the left-hand side because that's where the variable term is, and I need to get rid of the constant, so what's my next step? Not divide yet.
I'll subtract.
Subtract 350. You may actually be ahead of me. So I'm going to subtract 350 from both sides. It's the constant. That gives me 10x, those 350s have canceled, is equal to 100. Now my final step is divide by the coefficient, which is 10. That gives me x is 10. What did we just find?
That takes 10 gallons.
Excellent.
Pure acid
Yes.
To make a 90%.
That's exactly what it does. We got a 10, and so I'm asking you, what does that represent? It represents 10 gallons of pure acid that it takes to mix with what you had to get a 90% solution. Does that make some sense?
Yes.
Okay. All right, our last problem of this type, if I scroll back up, and together in just a second, we're going to draw the picture so that you have all the numbers you need, and then I'm going to be very, very quiet. I'm going to pause this recording, and I'm hoping you'll set up the equation and you'll solve it, and then we'll do it together. All right, number 3 says, how much pure acid should be mixed with, and this one is a 6, I believe, 6 gallons of a 20% acid solution in order to get a 40% solution. Okay, so I know that you may not remember all those numbers, but here we go. It starts out by saying how much pure acid. Pure acid, the percentage, we know is 100%. When it says how much, we know that's unknown, X. How much pure acid should you mix with 6 gallons, that's the volume, I wrote it on the outside, 6 gallons of a 20% solution in order to get, all right, here's what I'm creating, a 40% solution. The part that you have to figure out that is not implied in the problem is what's the volume of that one? What's it going to be? It's going to always be this volume plus this volume, X plus 6 in this problem. All right, now I'm going to pause the recording and I'm going to be very quiet for a minute, and I would like you to write the equation and then go ahead and solve it, and we'll take a few minutes. All right, I hope that you were successful in writing your own equation. What did you write for your first term? 100x, multiply the number that's the percentage times x, plus 20 times 6, and I know that you might have multiplied that in your head, equals 40, parentheses, x plus 6. All right, I'm going to go ahead and rather briskly solve that. I'm going to keep my 100x plus that product, 120, is equal to, use the distributive property, 40 times x is 40x, 40 times 6, 240. Okay, so I've simplified. The next thing, I have 100x on the left, I have 40x on the right. I want to get rid of one of them. I'm going to subtract 40x from both sides. That gives me 60x plus 120 is equal to 240. Now I focus my attention on the left-hand side, and I need to get rid of the constant, so I subtract 120. That gives me 60x is equal to, I have a leftover 120, divide by the coefficient, which is 60, and x is 2. And it is 2 gallons, even though you don't ever have to type in the units in MATLAB. Logically, it's very good for you to think about, what did I just find? I found x. X represents the number of gallons of pure acid that I have to mix to make this creation. Is that okay? All right, in MATLAB, in section, what are we on, 2.6, you only have 3 questions to do. And they will be very, very similar, and I hope you'll maybe keep your notes out while you work on that. Okay, I'm going to go ahead and stop this recording, and then we will pick up with 2.7.